All right, let's talk about how to build an atomic magnetron. First off, the magnetron in the picture is a standard microwave magnetron. Nothing special. You don't need anything special about this. What you do need, though, is a diamond tile saw that you can get from Home Depot or anywhere else. And it needs to be a wetted saw. You need it to you need to be very careful doing this. The dust from the ceramic can be poisonous from a microwave magnetron, depending on what type of ceramic they use to hold the filament in the magnetron. And you can't just saw this off in a clean saw. You have to go around the neck because you need to measure how far up in the filament is into the resonators. So you have to do this very carefully. You need a mask, eye protection. You need to protect your hands with gloves. You don't want the dust, the ceramic dust getting on your hands. You don't want to eat it or anything like that. It can be poisonous. So I'm just warning you up front. You have to be very careful doing this. So once you get to the point where you're cutting the bottom of the magnetron, you don't want to cut right next to the metal. You don't want to do that. You want to about 1/10 of an inch up from the metal. You want to start sawing into the magnetron filament end of it. And when you finally get to the point where you've got a little hole in there where you can see a vacuum, where you let the air back in the magnetron, from that point you want to take and twist the magnetron around very gently. And this ceramic is tough stuff. I mean, this is not like cutting tile. This is really hard. That ceramic is just as hard can be. So you want to do this very slowly, very gently. Like I said, wear the eye protection and the mask. You know, not just a standard mask. You really need a respirator mask that really covers your face, because you don't want to be breathing the particles in at all. So once you get the cathode cut out, you want to be very, very gentle. Those cathodes, the filaments can break inside the resonators, so you want to do this very slowly and very gently, because you don't really want the filament breaking apart and getting stuck in the resonators inside the magnetron. Otherwise, you've ruined the experiment. Once you get the filament out of the magnetron, you want to look at the bottom of the magnetron and the mounting holes. You want to make sure that the mounting holes and the hole that's going to allow the block that's going to be put on the bottom of the magnetron it's a high tolerance device. You want to make sure that the filament, the isotope that's replacing the filament, is dead center in the inside of the magnetron. You can't do this sloppy at all. You have to really work at making it dead center in there. So you got to be real careful about these mounting holes and make sure that the actual assembly of the magnetron is really in the center where the mounting holes are at. The next thing you're going to need is to make a non-conductive electrical block for mounting copper to it. And I used standard PC board. Fiberglass is what I used, but you can use acrylics. You can use anything that's plastic that's non-conductive that will suit your needs, that you can cut grooves into and you can drill it out without having it split and that kind of things. At some point you're going to have to apply 4,000 or 5,000, maybe 6,000 volts to this, but that's down the road. So you need a really good insulator, and I use standard PC board material that's thick, standard fiberglass that's in the picture here. You're also going to need to mount a vacuum port to the insulation block. So you need a pretty thick piece of fiberglass to mount the vacuum port to it. So this is a picture of what the block looks like with the vacuum port attached to it. Alright, so you're trying to get this built, and you're really trying to do three things. You're trying to get the vacuum port to work, because you need to really produce a vacuum inside the device, and you need a metal conductive bottom that connects to the isotope, and you need to be able to move the post up and down to adjust the level of the isotope inside of the magnetron. So this is the mounting base that really attaches everything to the magnetron. That's what you're trying to achieve here, and we're going to go through each piece of this, why it was done the way it was done, so that you have an understanding of what you're trying to achieve. Okay, what we're trying to achieve here, we've got a copper rod and we've got a copper base. Both of them are 1/4 inch copper. And if you've never machined soft copper, this is soft copper, and it pulls and tugs and breaks bits and everything else. So you got to be a pretty good machinist and do this sort of slow, and use plenty of machining oil to do this. But you wind up that you have to have a couple set screws in here, and you can see the set screws at the top of the copper rod. You can see the set screw at the bottom of the flat plate that's going to hook to the fiberglass. The flat plate will eventually hook to the fiberglass. So, and all this has to be conductive. And at the same point, don't forget you got a vacuum that's going to be pulling against that rod. So you're going to wind up having an O-ring or a washer or some type of sealant down at the bottom of that, so that it can keep a vacuum. So this is what you're trying to achieve here, and you just got to do it slow when you're machining it. All right, so we've got 2 mounting holes for the copper block that mount into the fiberglass that hold it. Remember that at some point you're going to pull a vacuum, so you're going to need to put some kind of sealant on this copper block at some point to make sure that you can maintain your vacuum. You also notice that if you look at this part of the block, that you can see the set screw runs all the way through the block to where the pole mounts in there, and that the set screw, again, at some point, you want it tight that it's not going to lose vacuum. So at some point you're going to have to seal the set screw up to maintain the vacuum. It's a lot of work doing this, and you're going to have trouble. You're going to break drill bits trying to drill this stuff. We did, and I'm sure you will too. This is the rod that holds the isotope. Now, most isotopes come as a little dot on a needle, or they come as a little rod, teeny tiny rod with something attached to it. And you need a way of connecting that to the copper rod. And the set screw, you got a little tiny set screw that can hold the needles or hold the metal rod that has the isotope on it, or the block of isotope. And you can't have the isotope any bigger than what the size of the filament was. So it needs to be a pretty small cross section that is much smaller than what the 1/4 inch rod is to do this. You can't have you've got to have the about the same distance as what the filament is inside the resonators, because there's a capacitance value that you may have to adjust for, and we'll go across the theory of how this all works in a different video. But this is just, you need the set screw to mount the isotope, and you need a way of moving the rod up and down to get the isotope in the right position and all that. So this is what you have to do to mount the isotope on the rod. At this point, we can mount the rod and the plate to the bottom of the fiberglass block and put in the standoffs at this point. And in the next picture, you're going to see that we put a piece of insulation around the isotope rod. Now, this will be needed in the future. I'm not going to go exactly into it, other than at some point you need a starter voltage, and that's high voltage, and that piece of rubber will keep the rod from arcing to the inside of the magnetron when you apply the starter voltage at some point. And it can be any type of insulation. You can use shrink tubing if you want, or expando rubber. We used expando rubber around the rod because it was easy and we had it in stock here. Alright, so at this point, after you've made sure that everything lines up right and fits down the hole, and that you have to worry about mounting the fiberglass block to the actual magnetron and using epoxy or some kind of sealant mechanism around the cathode base that you cut out of the magnetron to the fiberglass block. As you can see here, you can see the cathode base sticking through the bottom of the fiberglass block, and to be able to pull a vacuum on that, you need to seal that up. Doesn't matter how you do it, but it does need to be done. Now that you've gotten this far, there's one more test you have to do. You have to make sure that the rod and the base are not shorted to any part of the upper stage of the magnetron, the outside case or the antenna or anything like that. And at this point, you shouldn't have any isotope in it. And above all, you need to watch the video on the theory of operation before you try and start one of these things up, so that you understand how it's going to work, what's going to happen, and what can happen when you try and shut it off. So I'm going to go into a detailed explanation of how this actually works, because this works a little different than a standard magnetron does, and it acts a little bit different also.